Hello, good afternoon. I'm here to present my third tutorial on Abacus. In this tutorial, I will teach you the general addition and subtraction. As you may recall, in the last video, we did simple addition and subtraction. So what was simple addition and subtraction? So addition and subtraction where you always had enough beads to perform the operation in the given place value. That was simple addition and subtraction. Example, 3 plus 1. So I'm going to put a 3 and then to that I have to add 1. So I can slide one more bit, I get 3 plus 1 is 4. What if I have to do 3 plus 2? Well, 3 and then I have to add 2, but I don't have enough beads here. That is general addition. Okay, so the idea is that for adding a digit where you don't have enough beads, you have to use complementation. And I talked about it very briefly at the end of my second video, and today I'm going to elaborate that. So to add 2 to 3, you have to use the 5's complement. So adding 2 is same as subtracting 3 and adding 5. So therefore you get the answer as 5. So to work with this, kids have to first understand both the 5's complements and 10's complement. This should be under their belt. Once they have this, the rest is smooth sailing. So what is 5's complement? So if you take a number between 1 and 5, so let's say 1 through 4, any number, 5's complement is simply how much you have to add to that number to make it 5. And to help kids, we can ask them to use their fingers. So if I want the complement of 2, so just close 2 fingers, you get 3. If I want the complement of 4, close 4 fingers, you get 1. So 1 plus 4 is 5, 2 plus 3 is 5, 3 plus 2 is 5, and 4 plus 1 is 5. Okay, and you also need to know 10's complement. And for this, kids will be working with both their hands. So 1 plus 9 is 10, 2 plus 8 is 10, 3 plus 7 is 10, and so forth. And it's very easy if they understand the pattern here. So in the first column, numbers go up starting from 1 through 9. In the second column, they decrease from 9 to 1 back. So I think that is the first task for kids, to have these 5's complements and 10's complement completely memorized. And once they have these memorized, we can do the general addition and subtraction. Okay, so I'm going to begin with single digit addition and subtraction. And in fact, the general addition and subtraction can be reduced to the single digit case, and we will see that shortly. So let's work through these 6 problems, 3 on addition and 3 on subtraction, using this idea of complementation. So the first one I have here is 2 plus 3. So let's put a 2 here, and then I need to add 3. So, but I don't have enough beads. So I will ask, okay, I can't add 3, so I'm going to use the complement of 3, which is 2. So instead of adding 3, I subtract 2 and add 5. So the answer is 5. Next, 2 plus 4. Same deal. So you put a 2, and then you want to put a 4, but you don't have enough beads. So then you ask, okay, what is the complement of 4? The 5's complement is 1. So what you do is that instead of adding 4, you subtract 1 and add 5 to get a 6. The last one I have is 3 and a 7. So I'm going to put a 3. To that, I want to add a 7. So now, because you are more than 5, you should ask for 10's complement. What is the 10's complement of 7? Well, it's actually the number 3 itself, right? So instead of adding 7, I subtract 3 and add 10 in the, or 1 in the 10's place. So you get a 10, 1, 0, that's a 10. All right, so now let's recycle these problems to work subtraction. So if we do our math correct, we should get the top numbers. So 5 minus 3. So let's put a 5, and then I want to subtract 3. So I want to take away 3 beads. Well, I don't have 3 beads to take away here. So I'm going to use the complement, and the complement of 3 is 2. So instead of subtracting 3, I add 2 and subtract 5. 6 minus 4. So let's put a 6, and then I want to subtract 4. Again, I don't have beads, so instead of subtracting 4, I'm going to add 1 and subtract 5, because the 5's complement of 4 is 1. I'm going to add 1, subtract 5. So I get 6 minus 4 is 2. 10 minus 3. So let's put a 10. That's a 10. And you want to subtract 3. So what is the 3's complement? So the 3's complement is 7. Or actually, I can work with the 5's complement here. So instead of subtracting 3, I'm going to add 2, because the 5's complement of 3 is 2. I'm going to add 2 and I'm going to subtract 5. Well, I don't have 5 to subtract, so I'm going to use the 10's complement. So I'm going to add 5 and subtract 10. So to get a 7 there. All right, so that is single digit addition and subtraction. Now, as I said, the general addition and subtraction can be reduced to single digits. So to illustrate that, I have a couple of examples involving 3 and 4 digits. The first one is an addition problem. 856 plus 394. So it's a bit delicate problem, so we have to do this carefully. 856. So let's put 8. 5 and a 3, that's an 8. 56. 5 and a 1. All right, so first off, we need to add 3. So I need to add 3 here. Well, adding 3 is same as subtracting 2 and adding a 5 here. Well, I don't have 5, so I'm going to use the 10's complement. So I'm going to subtract 5 and put a 10 there. So I took care of the hundredths place value. So I guess at this point I should mention that unlike ordinary arithmetic where you go from units, tens, and hundreds, the convention in Abacus is you go from the highest place value, work your way back to the units place. So we just completed the hundreds place. Now let's look at the tens place. So I need to add a 9 here. So I want to add a 9 here. Adding 9 is same as in the tens complement, subtracting 1 and adding a 10. So I want to subtract 1. Well, subtracting 1, so I'm going to use the 5's complement. So that's adding 4, subtracting 5, and then I need to add a 10. So you have that. So, and then I need to add a 4 here in the last value. So adding 4. So do we have a 4 to add here? So we don't have 4, so I'm going to subtract 1 and add a 5 here. Well, I don't have 5, so I'm going to subtract 1 and add a 5 here. Add a 1 here, excuse me. But I don't have 1 to add, so I'm going to subtract 4 and add a 5. So yeah, one has to go through that carefully if that's confusing. So let's put what we got here. We got a 1, 2, 5, 0. 1, 2, 5, 0. In fact, as you can check, 856 plus 394 is, in fact, 1,250. All right, so the next example I have is 1250 minus 394. As you can see, I've been recycling my examples. So I'm doing 1250 minus 394. If I do my math correct, I should get 856. Now 1250, so we already have it ready-made here. It's already in place, 1250. To that, I need to subtract 394. So I have to do nothing in the thousands place value, but in the hundreds place value, I have to subtract a 3. So let's come here. So here I need to subtract 3. Well, what is subtracting 3? Subtracting 3 is same as adding 2 and subtracting 5. Well, subtracting 5 is same as adding 5 and subtracting a 10. Now, then I need to add a 9 here. So I need to add a 9 here. Adding 9, oh, sorry, I'm subtracting, right? Sorry, subtracting 9. Subtracting 9 is same as adding 1 and subtracting 10. So I'm going to take 1 off. And the last one is you subtract 4. Subtracting 4 is same as adding 1 and subtracting 5. Subtracting 5 is same as adding 5 and subtracting 10. So how much did we get? We got 8 here, 5 and 6. 856. I think that's it. So that's how you do general addition and subtraction using the idea of complementation. Thank you.